Hello everyone, welcome back to this series on data visualization in R. My name is Sophia, and in this video, we're going to be talking more about bivariate graphs, specifically about bivariate graphs that compare two quantitative variables. And this is something we already did once in the very first video, where we looked at the Bechdel test data. And we looked at two quantitative variables. We made a scatter plot. We put a line of best fit, or rather a regression line to the data and looked at it through that lens. So today we're going to be constructing a graph that's a little bit different. We're going to be making a line plot. And at first glance, you might think, oh, a line plot, like those are pretty simple, probably not as useful as a scatter plot, but they can be very useful, as we'll see in a second. And so what are the two variables that we're going to be looking at? Well, we're going to be looking at this variable lightness. It's a value from 0 to 1, 1 being a very light shade of makeup, and 0 being a very dark shade of makeup. And we're going to be comparing that to this numbers, and you can read the description, the numbers associated with the particular shade. That probably doesn't make much sense at first, but basically what that means is that a lot of times when a makeup company is making a palette of colors, a palette of shades, they'll often assign each shade with a number to keep track of them. And not every palette does this, but a lot do. So here's an example. Here they're not explicitly labeled with numbers, but you might have them go like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, something like that. Yeah, so basically each shade is like assigned a color and, assigned a number. And that's what this is referring to. And this turns out to be actually pretty important, as we'll see in a sec. But for now, let's just look at, the lightness value and the number that value is usually associated with. So the first thing we're going to do, this is coming from the all numbers data set. So let's load that into R using this code. Oops. And there we go. It's from the last video here. We don't really need this anymore. Yeah, so here, let's take an example. Yeah, here we have the lightness, and here we have the numbers. So for example, the traceless soft matte foundation called Cameo has a lightness value of 0.85, so it's pretty light. And it's usually it's at the beginning of the palette, so 0.1. And I'm not completely sure what the rationale is for this numbering system that they're using, but the idea is like the same, that if it has a smaller number, it's at the beginning of the palette. If it has a larger number, it's at the end. And we're not too worried about what the exact numbers are for this graph. So first, I'm just going to construct a basic line plot. And we're going to use, again, our ggplot2 package, which we've been using in every video because it's convenient. Again, it's the same format we've been using. You don't have to be too creative. We hit all numbers. Then we map our variables. We're going to have lightness on the x-axis, and numbers on the y-axis. Now we're going to add this another geom underscore method that's going to add a line. So it's going to make a line plot. So if you remember the command to add like a regression line was a little different. It was like geom underscore smooth, and then you had some like arguments in here. But for line plot, it's going to be geom underscore line. So don't confuse those. Yeah. Oh, I didn't run it. I just saved it. Sorry. There you go. So there's our line plot. Obviously, it does not look good at all. Not useful at all. But you can kind of see what's going on here. So the reason it's this crowded, right, is, well, we have so many values of lightness. And yeah, it's just, what's happening is it's just jumping up and down, because we have a value of lightness of like 0.25, but for 0.25 we have different numbers. We have like a 500, like a 2, I don't know, we have like different numbers going on. So instead of like, and this data right now as it is would probably be better suited to a scatter plot, right? We would just have a point here, a bunch of points, but here it's trying to like make a line plot, so it's just bouncing up and down between these points. So obviously it's not a good graph at all. And so one way we can solve that is by lessening the number of points. And we can do this first by sort of rounding these values. There's so many because they're so exact, right? We have like, I don't know how many significant figures, but a lot. And what we can do is graph it to like the nearest one, say, decimal place. And then we're going to have just like a few points, and we can see a clearer line going between them. So the way we're going to do this is by using a function called round, which is found in base R. No extra package at this time. So we're going to grab this column lightness using this format, and then we're going to just round. And then we're going to round it to just one significant figure. So like one spot after the decimal is what we're going to do. Yeah. All right, now we can try. It's still not going to look great, and you'll see why in a sec, but we can, yeah, I mean, it looks a little clearer, but this isn't very useful still. Especially, oh, that's another reason why it looks weird. So many of the values are going to be close to 0, right? With a few outliers that are very high. So actually what's going on here, I think, is that every time there's like a high outlier, it just like skyrockets. And then here it's like, there's like a lot of values here. And let's look at the actual numbers. So yeah, now we have it. Let's organize. Okay, let's say lightness is going from low to high. Yeah, now we have like, well, they're actually not too small. Yeah, it's going up until like 590 here. And then it's dropping, yeah, that's what's happening. It's dropping all the way back down to 1. And then it's kind of like growing again up to, oh, in this case, only like up to 8. So you can't even really see what's going on. Oh, never mind. It's going up to 580, up to here again, and then dropping back down. So that's what's happening. That's why it looks weird. So we need to figure out a way to fix this. And actually, we're going to do the same thing we did in the first video, where for each value of lightness, we're going to find an average an average kind of value for numbers. And then we can compare them a lot easier than looking at all the values of numbers. And this is something we did in the first video with the Bechdel test data, where instead of looking at all of the movies that came out in a particular year and comparing their their rating, we just took an average for each year, like an average rating, and then it was easier to compare between years. So that's what we're going to do again. And if you remember, the command we used then was, first we grouped, using this group by command to group by lightness. So now we're saying, okay, associate, that's because we need to hit this. Was it this one? It was DPLYR. Yeah, that's right. We need this package. We need to kind of open it until we can use this group by method as part of this package. So we had to run that package first. Okay, we should be good now. So we're grouping by lightness, where we're saying all of these shades that have the same lightness, let's group them together. And then we'll be able to find like the mean of the numbers associated with each lightness. Let's see. And now we're going to make a new kind of data set with means for each lightness now. And we're going to do that using the summarize method, which we used again before. It's part of this package. We're going to take data from all numbers, and we're going to make a new variable called mean numbers to replace just our regular numbers. I'm going to say mean numbers na.rm equals true. And again, if you don't remember, this little thing is going to remove any missing values. And this might actually be important in this case. It wasn't really important in the last case because there were no missing values. We knew that ahead of time. But for this time there might be, because not every makeup company assigns a numbering scale to their products. So in this case, maybe it automatically took those out, but we should do that here just in case. So we're going to remove our missing values, and we're going to this. Now we have our mean numbers. And yeah, now we have just a very few data points, which is pretty ideal for our line graph, because we want to be able to see really clearly what is going on there. Yeah, so let's just graph this same way we did before. Run. Oh, I forgot to do something, didn't I? Oh, that's right. Because we don't want to graph numbers anymore. We want to graph mean numbers. And instead of having just numbers on the y-axis, we want to have this new mean numbers variable. So now it should be good. Yeah, so here's our line plot. Obviously you can see it looks a lot better. We can actually see a trend in this data. So it looks like as lightness is increasing, mean numbers are, so it's not completely uniform, not completely constant, but it is. We can see that the average is decreasing very clearly. So before we really talk about what's going on here, let's make this line plot look a little better. And I'm not going to go through each step of this. I did this ahead of time, so I'm going to grab this code and I'll walk through it, but this is just to make it a little easier to look at. So so now we have these little points at each value, each lightness value, so we can really focus in on those points if we want to. We have our axes labeled. Let's just go back here. This is all the same as before. We added our line with, oh yeah, if you remember from our scatter plot, we have these arguments for our geom objects like size, color. There's also like alpha, which is transparency. We didn't really mess with the transparency here, but we did make the size of the line. We made it a little thicker by hitting 1.5. We made it light gray instead of just black. And with these points, we made them, there weren't points before, so now we added points. And this is the exact same command we used in the scatter plot. So we could have just, instead of doing geom line, we could have just said this plus geom points, and it would have been like the beginning of a scatter plot, just a really like sparse scatter plot. The difference here is that instead of constructing like a regression line, there are so few points that it's easier to just, connect them. We can still make like a line of best fit here or something, but for us, it might be easier to just connect them and look at like what comes up. So here with the points, we made them bigger. We gave them color, and we labeled the axes in the title. So here we said average numerical label, because that's what we did. We computed like the average, and then we have the lightness value from 0 to 1, or in this case from 0 to 0.2 to 1 because of like the rounding. And we have a title, average numerical assignment for nude makeup shades. Yeah, and so let's take a second to actually think about like what we're seeing in this data. So again, a pretty clear trend. As the lightness goes up, the numerical value goes down. So what that means is like the lighter the shade of makeup we're dealing with here. And again, these are nude shades. These are like skin color shades. So the lighter these shades are, the more likely they are to be at the beginning of a palette, because they're more likely to have a lower number, which means they're going to be towards the start of the palette. And obviously we can see that this isn't completely constant, like there are outliers. But for this like really light shade, it goes up at the end here, which is kind of surprising. But let's say for this really light shade, it looks like things are right around 50 in comparison to like this darkest shade, which is higher than 300. So there's a big difference. It's not just like random, we took the average and zoomed in here. Actually, we should probably have this y-axis starting at 0. That's something that's, yeah, actually. Okay, so as we were recording this, I actually went and Googled like how to set the axes just to remind myself. So actually let's do that. Because I feel like that might give a little better picture of the data. We don't really care about the x-axis, but let's set the y-axis starting at 0. And we do that by, I don't think it really matters where you put this, but plus, I'm gonna have y lim going from 0 to, let's say 300. That looks like where it's at about here. Well, let's try this. And yeah, okay. I think this is a good thing. So automatically, yeah, it looks like a little more dramatic, and this is probably a bit more fair representation of the data. But still, you can see that there's still a very clear trend going on where this clearly isn't by accident, there's something going on here. And so the reason I actually graphed these two variables, you might have been wondering in the beginning, like, oh, those are so random, like who cares about where the shade is in like the palette, like that doesn't really matter. But it turns out it kind of does matter. And I got this idea from the article that's associated with this data. It's called The Naked Truth. Again, I recommend you go check it out. Very interesting. But they did kind of a similar analysis. They didn't do this exact same thing. They didn't make like a line plot, but they did a similar like analysis, and they found that this same thing, that lighter shades were much more likely to be at the beginning of a palette than darker shades. And a lot of makeup companies organize their shades that way. They go from like light to dark. That's their numbering scale. Very few go from dark to light. I mean, some are probably random. Some just have their shades scattered, but you know, it's probably aesthetically pleasing to have it go from like a little bit of a gradient. So a lot of them go from light to dark. And what this article was talking about was that actually this is like kind of contributing towards a bias where we view light shades as like coming first. And this might not seem like a huge thing, and it's, you know, it's not obviously the biggest problem that there is, but it is interesting to like see how often it comes up that these companies will put light shades first. And also this is like prioritizing a certain customer, you know, where we're saying, oh, because I think like, I don't have a huge experience with makeup, but it seems like the colors and the palettes that companies will put first in a palette are the ones that people buy the most. They're the ones that are like catch your eyes. That's like your target audience. And the ones at the end might be like some weird, so if it's like a mixed palette, you know, the ones at the end are usually like the weird colors that you might not use as often. So it's interesting to see how that might like give some sort of implicit bias or show some implicit bias from us. And yeah, now that we've like seen this graph, let's look at some actual like pictures, like makeup palette. And I bet we'll see this pattern just from looking at some pictures. Oh, this isn't really what we're looking for, but I would like to point out already here that we see some very light shades at the top, and at the end we see like, this is what I was talking about, these like crazy shades, crazy colors that you probably wouldn't use. I mean, you might use them often, but you wouldn't like use them all as regularly as some of these like more nude shades at the top. And still we see that these lighter ones are like closer to the beginning. But let's search up like nude makeup palette. I don't mean to go on a complete tangent here. I just thought it was, this is like a practical example of what we're seeing in the data. Yeah, so here already, the very first one, we kind of see this example of like things going from light to dark. There's some light shades here at the end too. And I don't know if this is the exact same numbering system that this was talking about. But I think it might be, you know, we go from like 1, 2, 3, 4, 5, 6, something like that. And darker shades are ending up closer to the end. Again, here, we have darker shades at the end, lighter shades at the beginning. Here, same pattern. And, you know, it's not completely uniform. There are some darker shades at the beginning, but this one's like basically a gradient, you see. Yeah, so I just thought that was interesting to see in the data and to see an example of. So yeah. I think I'm going to end this video right here. And in the next video, we're going to talk about our final type of bivariate graph, where we're going to be comparing a quantitative variable to a categorical variable. But actually, before I end this video, yeah, there's actually one more thing I wanted to talk about, which was that we could have represented all this data in a scatter plot instead of a line plot, right? We could have, I mean, as it is right now, this is definitely, I think, better for a line plot because there's so few data points. But before we like made all those like choices in our filtering and rounding, we could have had like a little cloud, like a cloud of points in like a scatter plot here, right? And we could have had a regression line going through it, and if we found the equation of the regression line, we would have seen a negative slope, like a negative correlation, and we would have seen like the same trend. But you know, this is just a different way of visualizing this data, and you know, as statisticians, we can all make choices on like which one is better in the moment. This is probably a bit like easier on the eyes. You don't need to spend as much time looking at it, but On the other hand, the scatter plot might contain more information because we'll have a whole cloud of points instead of just these like 10. So yeah, that was the last point I wanted to make. And I think I'm going to end this video here. So in the next video, we're going to be looking at the last type of bivariate graph, where we're going to be comparing a quantitative variable and a categorical variable. So I'll see you guys then. Thank you for watching.